Today we will talk about wave motion. As we know, motion can be classified into transitional motion and periodic motion. Transitional motion, a motion that has start point and different end point, like motion in straight line and motion in curved path. Periodic motion, motion that repeats itself in equal interval of time, like oscillatory motion and wave motion. Examples of oscillatory motion: pendulum, tuning fork, spring, or yo-yo, or vibrating string, violin strings, and so on. Energy transformation during the motion of the simple pendulum. During the pendulum motion from X rest position to Y, that's maximum displacement, the height increases gradually with respect to the equilibrium position, and its potential energy increases, and its kinetic energy, as we know, decreases because its relation inversely proportional. So, where kinetic energy converts gradually into potential difference according to law of conservation of energy, which states that the summation of kinetic energy and potential energy remains constant at any point. As kinetic energy decreases, the velocity decreases, because we know kinetic energy equal half mv squared. So kinetic energy decreased, so the velocity decreased until it reaches to 0 at the highest point. To study oscillatory and wave motion, we must know some terms and concepts. First one, displacement. Displacement is a vector quantity and measured in meters because it's a maximum displacement or maximum distance. Second one, amplitude. Amplitude is a maximum displacement of a pendulum from its rest position or equilibrium position, and it also measured in meter, but it's a scalar quantity. Complete oscillation. Vibrating body went through the same phase two successive times, it had made a complete oscillation. Like what? When a pendulum is moved from x, y to x to z, then returns to its rest position, it's called x. Number 4. Periodic time. Periodic time is time taken to pass by the same point two successive times in one direction, or the time taken by pendulum to make one complete oscillation, and its measuring unit is second. Frequency is the reciprocal of periodic time, or the number of complete oscillations per second. Periodic time T equals T over N. The frequency is the reciprocal of periodic time, so its rule nu equal N over T. Okay, and its measuring unit is equal hertz. Test your understanding. Number 1. The ratio between the time of the amplitude and the time of the complete oscillation is 2, 2 over 1, 4 over 1, 1 over 4. As we know, the relation between the complete oscillation and the amplitude, the complete oscillation equals 4 times amplitude. So the time of amplitude to the complete oscillation is equal 1 over 4. Number 2. If a vibrating object makes 90 oscillations in 1 minute, its frequency equal, as we know, the relation between the frequency and the number of oscillations, nu equal t n over t. N equal 90 and t in second equal 1 times 60, so the frequency equal 1.5 hertz. Number 3. If a vibrating object takes 0.1 second to complete one oscillation, so the periodic time is equal 0.1 second. The number of complete oscillations that's made by the object during 100 seconds equals time t small equal 100 and t capital equal 0.1. As we know, periodic time or t capital equal t small over n. T capital 100 equal 0.1 over n, so n equals 0.1 over 100, so it's equal 1000. Okay, last one. Sample pendulum takes 0.01 second to reach the maximum displacement from the equilibrium position, so its frequency equals the sample pendulum takes 0.1 to reach the maximum displacement, so the periodic time 0.01 times 4, so the frequency equals the reciprocal of the frequency, so it's equal 1 over 0.04, so the frequency equal 25 Hertz.